Okay, these notes are specifically to just get more acquainted with the unit circle, to find a couple of uses for it. I just want to explain some stuff again that we talked about in class that maybe you didn't catch or didn't listen to or didn't understand. So we have here the unit circle, and what this means is we have 4 quadrants: x-axis here, y-axis. Okay, same thing as we were used to. 1, 2, 3, 4. These are the quadrant numbers here. You see this here. And as you look at this, the x and the y are both positive over here in quadrant 1. In quadrant 2, the x is negative, the y is positive. That's what this is talking about. In quadrant 3, the x is negative, the y is negative. And in quadrant 4, the x is positive, the y is negative. That's what this is talking about. Okay? Now, we have a degree measure: 0, 30, 45, 90, and so on. We also have a radian measure because there's a equivalent. In radians, 0 is still 0. But in radians, 30 is pi over 6, 40 is pi over 4, and 60 is pi over 3, and pi over 2 is 90, and so on. So each one of these here are representing the corresponding degree angle measure. And so we put that in our chart earlier as we were filling out our own unit circle. So that's what the degree numbers are and the radian numbers are. Notice that there are parentheses around, or ordered pair points around this whole circle. That means, remember, every point is x first, comma, y second. X, y, x, y, all over here is x, y. Here you go, 1, 0, x, y, x, y. All these points are in the same order of x, y. Even our signs is kind of giving us that x, y implication. And so we need to discuss that point real quick. A lot of this stuff we may have discussed before. I just want to make sure you guys see it again, hear it again. A unit circle is a circle with a radius of 1 for every point x, comma, y. Radius of 1 is important. The value of r is 1, therefore, therefore, an angle theta in the standard position, and we talked about standard position before, that is sine is y, cosine is x, and tangent is y over x. It says here, so the coordinates of the point can be written as cosine, comma, sine. So what does that mean? That means if we take a moment to actually go back to our unit circle, to our unit circle, every single one of these here, x, comma, y, that's really cosine, comma, sine, cosine, sine, cosine, sine. Over here, cosine, sine. This is cosine, this is sine. Okay, so what does that mean? Well, if I ask you to tell me what is the cosine of 210 degrees, well, let's go find 210 degrees. Oh, here it is right here. The cosine is the x coordinate, negative square root of 3 over 2. If I ask you for the sine of 30 degrees, that would be 1 over 2. What about the cosine of 5 pi over 6? 5 pi over 6 is here, which is the same thing as 150 degrees. The cosine will be negative square root of 3 over 2. And so they do stuff like that. And so that's what we need to make sure we remember, that the x is the cosine, the y is the sine. Also, guys, don't forget that we know cosecant, cotangent, and secant. Remember, the cosecant is the reciprocal of sine. So if I asked you for the cosecant of 150 degrees, it would be to take the sine and take the reciprocal of it. So instead of 1 over 2, it would be 2 over 1 or 2. Okay? Don't forget that tangent is y over x. Tangent is cosine, actually is sine over cosine. So that means it's y over x. That's what the little diagram showed just a second ago. So if I wanted to know the tangent, I would take this divided by that and put it in my calculator. We should know how to do that without a calculator, but I understand. So what you need to understand is that how to find the tangent. They only talk about the cosine and sine here, and so you have to manufacture the tangent. Now, over here, I actually give you what the tangent is right here. They're telling you what the tangent is on each one of those, but they don't do that all the way around. So you have to figure it out by, they got this by doing this divided by this, and it simplifies to square root of 3. And then they did this divided by this, and it simplified to square root of 3 over 3. Okay? Next. Okay, I said next, but let me just show you this, just to be clear. We don't necessarily need to know this stuff. We actually already have talked about it, believe it or not. Here's tangent y over x, what I just talked about. R is basically your radius, and you can find that by this formula here. But what you'll find out on the unit circle over and over and over again is that the radius is always 1. So we don't need to know this formula right here, because it's always 1 right there. This may come up sometime or another, but whenever we're working with the unit circle, our radius is always 1. Just wanted to put that in there. You might want to just have that in your notes, that formula there. So x is still x and y is still y in this formula here, the traditional x and y. Okay, so just for viewing purposes, I showed you this in class, but I just want to make sure that you have a complete unit circle, and you could pause it if you need to. Let's jump down to actually using it to do a problem or so. Let's look at these two examples here. If you think you can do them, then don't wait on me. Go ahead and do them. It says use the unit circle to find the exact value of each trig function. All right. So cosine, excuse me, of 210. The cosine of 210. Okay, so the exact value of the cosine of angle 210, it says the point passes through the point here. Let's go back to our unit circle. Here's 210 right here. The cosine is always the x. We just talked about that. So the answer is negative square root of 3 over 2. So the exact value of the cosine of 210 is square root of 3 over negative square root of 3 over 2. Now notice on B, they want 5 pi over 3. It tells us the point that it passes through, but let's just go find 5 pi over 3 in the unit circle. All right? Do you see 5 pi over 3 anywhere? All right? 5 pi over 3 is here. Since they want the tangent, think about this. The tangent is always sine over cosine. Sine over cosine, because both of those are, the 1/2 is cosine, the negative square root of 3 over 2 is the sine. So in order for me to find a tangent based on these two that were given, what I have to do is do the sine over cosine. So I actually have to do sine over cosine, which equals negative square root of 3 over 2 divided by 1 over 2. Now, how do you work that? Let's just put it in the calculator. All right, so you can actually put this in your calculator, and notice I left off the negative up here. So I'm going to just put a negative in there. All right, so as I put that in my calculator, I notice that now I can just hit enter, and look, it gives me the square root of the negative square root of 3. So that means that the tangent is negative square root of, sorry, couldn't see that. The tangent is negative square root of 3. What if I ask for the cotangent? What if I ask for this? Then I would find the tangent, and then I would take the reciprocal of that. So what I would do is I would put 1 over negative square root of 3 and hit enter. And then it tells me that negative square root of 3 over 3. Now, they didn't ask me for cotangent. I'm just saying we need to know how to find the reciprocal, or that cotangent is the reciprocal of tangent. Talk about a reference angle. And in plain English, a reference angle is always the shortest distance to your x-axis. No matter where the angle is, it's the shortest distance to your x-axis. And so here is how you go about finding trig functions and reference angles. And I'll show you that in a second, but you need to understand that a reference angle is going to be the shortest distance to your x-axis. So no matter how big the angle turns out to be, then you take that and draw the shortest distance to the x-axis, and whatever that angle degree from the x-axis to that angle is your reference angle. And so this is talking about how you would do that. All we need to remember in order to figure the trig functions out in reference angles is another chart I showed you guys in class, and it's on your unit circle as well, where things are positive and negative and what quadrant your angle turns out to be in. Okay? Let's look at this example here. You can pause that and go back if you need to, but let's look at this. It says use a reference angle to find the exact value of sine, cosine, and tangent, all right, of 225. So when we go looking at angle 225, if we look at our unit circle, angle 225 degrees is right here. And notice what they've done. You go all the way around the 225. Remember, a reference angle is the shortest distance to your x-axis. Going around this way would not be the shortest distance. Only this would be the shortest distance. And so what's the difference between 180 degrees and 225? Because this line right here is 180 degrees. Okay, remember, half a circle is 180 and this is 225. The degree measure will be 45. So that's how they figured that out. Okay, this is 45 degrees. So that's what they said step 1 is, to find the measure of the reference angle, which is 45 degrees. Step 2, find the sine, cosine, and tangents of the reference angle. And I'm doing this in quadrant 1. So when I go to quadrant 1, the sine, cosine, and tangent you can find from right here. Square root of 2 over 2 is both sine and a cosine. And the tangent will be 1 when you divide them by themselves. And so that's what this is saying. Cosine 45, sine of 45, and we got these all from quadrant 1. Now, since this angle here, pay attention, is in the third quadrant, notice what we notice here. The sine is actually negative in the third quadrant. The cosine is actually negative in the third quadrant, and the tangent is positive. So what does that mean? This now becomes negative. Cosine now becomes negative. The tangent was already positive, and so it stayed positive. So what actually happened here, to summarize? Well, I used the values in the first quadrant. Once I figured out what the reference angle was, I flipped over to the first quadrant in my unit circle, and I noticed that, hey, 45 degrees is this for sine and cosine, and now I was able to figure out the tangent. But since I'm dealing in the third quadrant, I have to remember what's negative and what's positive in each quadrant. So that comes up from time to time. All right? You can actually take a look and see what the answers are to each one of these. And you can pause it, and then I'll put up the answers here in a second. All right. So here you go. Now, just real quick, this is like 90 degrees. So the reference angle is just 90 degrees. It doesn't change, okay? Sine of 11 pi over 6 is 1/2. Now think about this. 11 pi over 6, according to your unit circle, is 330 degrees. And so the reference angle would be 30 degrees. Or is that negative 30? No, that's 30 degrees. All right, and there you go, all the answers. If you got questions on those, let me know, and we'll talk about them in class. We'll do more, but this is just getting more familiar with the unit circle. We'll be using this a lot to help us figure out quickly what is the value of tangent or sine or cosine of any particular angle. All right.